Hello Year 10, it's Miss Bailey here. In this video we're going to be looking at acids, alkalis and concentration. So just a quick recap from Key Stage 3, acids and alkalis. These are two examples of hazard symbols, which tells us that there's something we need to be aware of with the substance that they've labelled this with. Pause the video whilst you have a think. Can you remember what these hazard symbols mean? So the one on the left means corrosive. So this is something that both acids and alkalis can do, is that they can corrode metals, but also you can see here, dangerous for our hands as well. And then the exclamation mark means warnings. That means that we need to be careful as the substance poses a hazard. So there are some examples of everyday acids, which I'm sure you will have come across before. So Coca-Cola, vinegar, citrus fruits such as lemons, tea, soda water, and then also some everyday alkalis, bleach, shampoo, soap, toothpaste, indigestion tablets, and bicarbonate of soda. What we use in school are quite different to those everyday acids and alkalis that we've used. So these are three common industrial acids that we would use in a laboratory, and here you can see the hazard symbols on here, slightly different to the ones that we used a few slides ago. The diamond shaped ones are the modern up-to-date versions of these. So in each of these examples you can see that I've put the hydrogen in the chemical formula in red, and that's because when our acids dissolve in water, they release these hydrogen ions to that solution. So all of these acids contain hydrogen ions that they can release when they dissolve in water. These are two examples of industrial alkalis. So here you can see I put the OH in purple because this is what alkalis release when they dissolve in water. So both calcium hydroxide and sodium hydroxide contain the OH ions. And we can also talk about concentrated acids versus dilute acids. So pause the video whilst you have a think about what's different between our concentrated acid on the left and our dilute acid on the right. So what you should have seen is that we have lots of H+ ions in our concentrated acid, whereas we have few H+ ions in our dilute acid. And the crucial point to note here is that we have the same volume of our solution, but in our concentrated we have lots more H+ in that given volume, whereas our dilute we have fewer particles in that same given volume. And similarly with our alkalis, we have lots of particles in the same volume for our concentrated. So here we've got lots of OH-, whereas here we have few OH-. So considering the difference then between those four solutions that we've looked at, what I'd like you to do is having a go at drawing for yourself an example between a concentrated and a dilute solution. You don't need to use H+ or OH-, we're just making this generic, but just so that you know the difference between something which is concentrated compared to something which is dilute. Pause the video whilst you have a go at this. So the way in which we define concentration, which hopefully you've seen or at least got an idea of from your diagrams, is that it's telling us how much of a solute is present in a known volume of a solution. So solute is a word that you will have come across before, and this is referring to our substance, such as a salt, which is dissolved in a solvent, such as water. And in each case we're using a known volume of the solution. So we have a standard volume which we are comparing the amount of substance into, and that we use is a litre. So can you please make a note of this definition of concentration? This is an example of some detergent which has a high concentration. So our dilute solutions have a low concentration, and we can make them dilute and therefore safer for us to handle by adding water to them. And this is something that you've probably done before. So here we've got an example of Robinson's fruit squash. So in the bottle it's concentrated, but for us to drink it and so it tastes nice, we dilute it by adding a little bit from the bottle into our glass and then adding water to dilute it. And you can also see there that because this is a colourful substance, that we have a colour change between our dilute and concentrated solutions. But for colourless solutions, we're not going to have this indication of whether something is concentrated or dilute. So this is the part which I would like you to note down in your notes, is that we can make concentrated solutions dilute by adding water. So pause the video whilst you note this down. So you will come across these two types of units in questions. So decimetre cubed, this is the unit we want our volumes to be in. But centimetre cubed, this is often what we will see in our questions, and so we have to be able to convert between centimetres cubed to decimetre cubed. But centimetre cubed is typically what we would measure our substance in, but decimetre cubed is what we use for our concentration. And that's because 1 decimetre cubed is equivalent to a litre. In a decimetre cubed, there are 1,000 centimetre cubed. And a centimetre cubed is actually equivalent to a millilitre. So whenever we're using measuring cylinders and beakers to measure volumes of liquid in school, we are actually measuring that in centimetres cubed. But when we talk about concentrations, we compare it to the equivalent to a litre, which is a decimetre cubed. So 1,000 times the milliliter. So what we need to be able to do is convert between these two units. So centimetre cubed and decimetre cubed, these feel quite new to us. However, their equivalent units, millilitres and litres, this is something that we're more familiar with. And so thinking about it in terms of converting between millilitres and litres might be easier. So in 1 litre, there are 1,000 millilitres. And so comparing those two numbers, what we've had to do to go from millilitre to litre, just like going from millimetre to metre, is we've had to divide by 1,000. Whereas going from 1 litre to millilitre, just like going from metre to millimetre, we've had to times by 1,000. And so it's exactly the same for our centimetre cubed to decimetre cubed, and for decimetre cubed to centimetre cubed. If you can't remember which way round these divide and times go, it might be helpful to know the conversion between centimetre cubed to millilitre and decimetre cubed to litre, because this conversion here is one that we are more familiar with. So here are 3 questions for you to have a go at, if you can pause the video whilst you do this. So the answers here is 0.250 decimetre cubed, 0.5 decimetre cubed, and 0.020 decimetre cubed. So we've talked about this fact that concentration is our amount of substance in a given volume. We might have used the word amount per volume. And whenever we hear that word per, we know that we are then dividing something. So thinking about our units of speed, metres per second. When we're calculating speed, we do our distance in metres divided by our time in seconds. So with our concentration, we're looking at our amount of substance in a given volume. And we've established that our units of volume is decimetre cubed. So what we then want to think about is how we could determine the amount of substance that we have. So a few slides back, we were talking about dissolving salt in a solvent. So how could we determine how much salt we have? Pause the video whilst you have a think. So one way in which we can determine our concentration is by considering the mass of a substance. And for that we use the units of grams. So for these, our concentration units then become grams per decimetre cubed, looking at how much in terms of mass we have in a given volume. So what I'd like you to do is apply this equation to these 4 questions. We will do 1A together and then you can have a go at 1B, C and D. So what we need to identify first is what we have from this question. So we've got 10 grams of sodium chloride. So this is our mass. And we've been given a volume here of 2 decimetre cubed. It's in decimetre cubed already, so we don't need to do any conversions, but you might need to for some of the later questions. So then to work out our concentration, we're going to be doing our mass, which is 10 grams, divided by our 2 decimetre cubed. So 10 divided by 2, that comes out to be 5 grams per decimetre cubed. So pause the video now whilst you have a go at B, C and D. So the answer to B is again 5 grams per decimetre cubed. For C, our answer is 15.2 grams per decimetre cubed. And for D, 17.1 grams per decimetre cubed. You now have a worksheet that's attached on the Padlet to be completing. So here we are calculating our concentrations. So just like what we did on the PowerPoint, doing our mass divided by volume. Remember where we can see our units in centimetres cubed, we're going to have to do that conversion into decimetres cubed to start with. And then for questions 2, 3, we're going to need to rearrange this equation so that we can find firstly here our volume for question 2 and 3 we are after our mass. So when we are thinking about rearranging this equation, we want to be thinking about moving our term from one side onto the other so that we can make it the subject. And to do that, we need to do the opposite of what's currently being doing. For number 4, we need to convert our masses first into moles. I will show you now how to rearrange the concentration equations and also for that question 4, how we can get our masses from our moles. If you are feeling confident, please go ahead and have a go at the problems. You can always come back and check if you've rearranged it after you've had a go yourself. So for this question, we need to get our volume of water, so we need to get it in terms of volume equals. So to get it onto the left hand side, we need to times both sides by volume, but there we get volume times our concentration is equal to our mass. So we then need to get our concentration onto the other side. Here concentration is being multiplied, so to get it onto the other side, we're going to need to divide, so mass divided by concentration. And then for this question, we need to rearrange our equation in terms of mass equals, and that we've done up here already. So our volume times our concentration. And so for our moles calculations in question 4, if we remember from our previous lesson that mass is equal to our moles times our MR, we can then use this to get our mass. We have our formulas for A and B. Nitric acid is HNO3 for each of these. And so we can get our MR from these chemical formula. Thank you all for watching and see you next time.